In this lecture video, we're going to be looking at partial residual plots. Now, what are partial residual plots? What are they used for? And how do we construct them? Well, partial residual plots are another tool that we can use to help us determine whether we have correctly specified the relationship between the expected value of the response variable and the explanatory variables in the model. The difference between a partial residual plot and a regular residual plot is that the partial residual plot is looking at the marginal contribution of a particular variable and its contribution in accounting for the variability in the response variable given all the other variables in the model. Now, the word marginal here is being used in a different sense than it's typically used in statistics. It's being used in a manner that is in the way that it's typically used in economics. The idea being in this sense, the contribution of a particular variable given all the other variables in the model. So how do we construct a partial residual plot? Well, suppose that we want to get some information on the importance of the relationship and the nature of the relationship between y and some regressor, let's call it x sub I. And so to construct a partial residual plot to give us some information on that, at least conceptually what we could do here is the following. We would fit two models, the first model being a regression of the response variable y against all of the other explanatory variables in the model except the explanatory variable of interest, in this case x sub I. And then we would calculate the residuals from that model. Now, the residuals from that model are the variability in the response that is not accounted for by the other explanatory variables in the model. Now, the next model that we would fit would be a regression of the explanatory variable of interest, x sub I, treating it as a response variable and regressing that against the other explanatory variables in the model. And once we have that, then we calculate the residuals from that model. And so when we do this, we have two sets of residuals, one set from each of the two models. And the corresponding residuals in those two data sets are paired because they are for the same observation. So the first residual in the first data set from the first model would go along with the first residual in the second data set from the second model, and so forth. And so we have ordered pairs of these residuals, and then we would construct a scatter plot of those residuals. And if we see trends in such a scatter plot, then we can interpret that as meaning that the variable of interest is important in the model. There is a relationship between the response variable and that particular explanatory variable above and beyond that which is accounted for by the other variables in the model. And so the idea here is that with the first model, the residuals from that first model are the variability in the response that is not accounted for by all of the other variables in the model, excluding x sub I. The residuals in the second model correspond to the variability in the explanatory variable of interest, x sub I, that is not accounted for by the other explanatory variables in the model. And so that is why when we look at scatter plots of these two sets of residuals, if there's a trend in that scatter plot, then that's telling us, it's providing information to us that there is indeed a relationship between the response variable and the explanatory variable of interest, x sub I, that is not already accounted for by the other explanatory variables in the model. And so as we see here, the interpretation of a partial residual plot, if the plot appears to be linear, then a linear relationship exists between y and x sub I, or at least it's reasonable that would be the case. And so we would want to then include x sub I in the model. If the plot is curvilinear, we may need a quadratic term for that particular explanatory variable, or some other form. For example, 1 over x sub I would give us a curve as well. So it depends on the nature of that curvilinear relationship, whether it would be a quadratic term or an inverse term like that. Now, if x sub I is a candidate variable that we're considering including in the model, and a horizontal band appears, then what that would indicate is that the variable really adds no new information. It does not account for any variability in the response above and beyond that variability, which is already accounted for by the other explanatory variables in the model. And so we would not want to include that variable in the model. And so here are a couple partial residual plots for example 4.5. And we're going to see how to construct these in SAS. But we can see here that there is a relationship in this partial residual plot. In the first one, this is the partial residual plot for x1 in this data set, which is the number of cases. And we see here a fairly strong linear relationship. And so this would tell us that the variable x1, the number of cases, is indeed accounting for variability in the response variable delivery time above and beyond that which is already accounted for by the distance that the delivery person has to walk. And similarly, in the second panel here, we see a linear trend with an increasing trend. And what this tells us, by the way, and so this is the partial residual plot for x2 distance. And what this tells us is that distance is going to account for variability in the response variable delivery time above and beyond that which is already accounted for by x1, the number of cases. Okay, so some caveats. The authors tell us here to use with caution. They only suggest possible relationships, and that's really the case for any kind of plot that we're looking at. They, in general, do not detect interaction effects. If multicollinearity is present, then regression plots could give incorrect information because it's difficult to evaluate the impact of a single variable if that variable is highly correlated with one or more other variables in the model. Now, interestingly, and we're not going to prove this, but we'll just point this out, that the slope of the partial regression or partial residual plot is the regression coefficient for that variable of interest in the multiple regression. And so the slopes of the fitted lines for these partial residual plots would actually be the coefficients for that variable in the multiple regression model. Okay, so next we're going to look at SAS, and we're going to do example 4.5 in the textbook. Again, this is the delivery time data set, and we're going to be doing a partial residual analysis. And we're going to be focusing in this lecture video on using PROC reg to do this. And so this SAS program does the following things. First, we're going to use PROC reg to fit separate specific models from which to obtain the partial residuals required for constructing the partial residual plot for the variable x1. And then similarly, we're going to use PROC reg to fit separate specific models from which to obtain the partial residuals required to construct the partial residual plot for x2. And then once we have those two sets of residuals, we're going to use PROC SGplot to construct the partial residual plots discussed above. And then finally, after we do that, after we implement this conceptual idea that we've been talking about, we're going to show how to get the partial residuals and the partial residual plots directly from PROC reg by using a few options in the one in the model statement, and the other option being on the invocation of PROC reg. So let's take a look. Let me scroll down here, and we've got the data step to construct the delivery time data set. So we will bypass that. We've seen that many, many times. And the first thing we're going to do, oh, by the way, I do want to point out one thing. So I've got this data step where I'm creating the data set, but then I have it looks it's an unusual looking type of data step. And what I'm doing here is, after I've constructed the data set, I'm going to go in, I'm going to create a new variable, which it's going to be called, it's an ID variable. I could have called it observation number or whatever, but I'm going to call it ID. And I just want a sequential number. I want a variable that has the observation number for each observation in the data set. So the first observation in the data set will have an ID of 1. The second observation will have an ID of 2, and so forth. And what I do is I open up the data set, delivery time data set. I do that with these two statements. This essentially creates another, it opens up that data set, creates a temporary version of it. We've already got that. When we use the set statement, it says, okay, bring in the data from this data set. Well, it's the same data set. So basically, I'm just opening it up for modification. So to open up a data set for modification, this is how you would do it. And then there's kind of an abbreviated syntax here for creating the variable that I just described. And the syntax is of the variable name, which in this case is ID, and then +1. And the way that the data step interprets that, it's going to initialize, it's going to create the variable. And then for the first observation it's going to initialize that counter, or that value, that variable to 0. And then as it cycles through each observation in the data set, it's going to increment that value by 1. So for the first observation, it would increment it by 1. And so ID would be 1. When it gets to the second observation in the data set, it'll increment it again. And so ID will be 2, and so forth. So that's how we actually implement creating that ID variable. And let me just show you what that looks like. So I'll run the code up at that point. All right, and you can see here that the last variable in the data set is the ID variable, and it has these values numbered sequentially, starting from 1 for the first observation down to 25 for the last. So I'm going to need that. It's going to come in handy to have that variable for doing some data stepping that I'll do subsequently. Okay, so the first, let's see here. Let me move this over a little bit. Okay, so the first thing we're going to do is fit a regression model with y as the response variable and x2 as the explanatory variable, and then save the residuals for that fitted model or of that fitted model. And so that is the description I have here in the title. And so you can see here that I'm invoking PROC reg, and the model statement has y as the response. It has x2 as the only or sole explanatory variable. We've left out x1. Okay. And then what we're going to do is we're going to save the residuals from that model. Now, I really don't need much of this information here, but I'll leave it in. What we're really after here are the residuals from this model. And so we get those residuals by specifying the R option on the model statement. And then we issue the output statement, and we give a name for the output data set. And I'm going to call this data set that I'm creating y underscore x2 underscore residuals. And so this portion of the data set name corresponds to the model that I'm constructing. So y is the response, x2 is the explanatory variable, and we're calculating residuals for that model. And then I want to save the raw residual out to that data set, and I'm just going to call that variable, or that I'm going to give it a variable name of residual. All right, and then what I'm going to do is, because I've got several of these data sets, residual data sets that I'm going to be constructing, I'm going to go back in and I'm going to do the same kind of thing that I did above. I'm going to open up this output data set for some modification. And what I'm going to do is I'm going to create another variable. I'm going to call it y underscore x2 underscore resid. And this is going to hold the actual value of the residual. Now, I could have just renamed the residual variable. There's a way to do that when you issue the set command. But the reason I'm not going to do that is because when we go to plot these things in PROC SGPlot, it's going to use by default as the axis labels the label information that's if it exists in the data set. And the problem is that when we output these residuals to this output data set, SAS is giving a textual description as an attribute for that variable. And it's going to be the same for each of these models. And it's kind of difficult to change that. It's just easier to create a new variable. And there's no label attribute active with that variable. And so it's going to be easier for us to identify the axes on the plot if we do it this way. So that is what I'm doing here. And then just so that I can verify what's being output, and I can actually see the values of those partial residuals, I'm going to print out that residual data set. Okay, the next thing we're going to do is something very similar to this, but in the next model, we're going to fit a regression model, again, with y being the response variable, but this time x1 as the explanatory variable. And then we're going to say the residuals of that model. And so everything is the same here as it was up above, except the model statement. Instead of the explanatory variable being x2, it's now x1. And then the output data set, in this case, is y underscore x1 underscore residuals. So this reflects this model. And then I'll do the same kind of data step where I open up this output data set for modification. And then I'm going to take the residual variable and I'm going to copy that into another variable, a new variable that I'm calling y underscore x1 underscore resid. Okay, just like I did up above. Now, and I'll print this out again so that we can check the values. Okay, the next thing I'm going to do, again, a very similar kind of thing, but in this case, the response variable is x1 and the explanatory variable is x2. And so that is reflected in the model statement. And then it's also reflected in the naming convention, the name of this output data set that I'm using. And then I open up that output data set for modification. And again, I'm going to create a copy of that raw residual value variable. And I'm going to call it x1 underscore x2 underscore resid. So this is going to be the residual from a model that has x1 as the explanatory variable, and I'm sorry, x1 as the response variable and x2 as the explanatory variable. And then we'll print that data set out as well. And then finally, we are going to construct a regression model with x2 as the response and x1 as the explanatory variable. And so that is reflected in the model statement. The output data set containing the residuals for that model reflects that model. So x2 underscore x1 underscore residuals. Again, what I'm going to do is open up that output data set for some processing for modification. Again, we're going to create a copy of this residual variable, and we're going to call it x2 underscore x1 underscore resid. Okay, and then once we do that, there's a little bit more processing that we've got to do, a little more data stepping, I like to call it. And we're going to create a data set containing the partial residuals from all 4 of these models. And so we're going to call that a new data set, residuals. And so I create that new data set with the data statement. And then I've got these 4 data sets that I want to combine, and I want to line them up so that the first observation in each of these data sets corresponds to the first observation in the original data set, and the second and the third and so forth. So I've got this output data set containing residuals, this data set containing residuals, that one, and that one. So I've got those 4 data sets with residuals from the 4 models. And again, based on our naming convention, you can easily see which model these are the residuals for. Now, the way that we line these data sets up, it's called merging in SAS. And so we're going to use the merge statement within the data step. All right, and then we just list the 4 data sets that we want to merge. And they have to be structured and organized correctly. They have to be in the same order. All right. But then in order to tell SAS or tell the data step to line them up and to connect them, so connect the first observation from each of the data sets together, we're going to merge, and we're going to merge by ID. And that is the reason why we constructed that ID variable to begin with. Okay, once we do that, then we will have put all of 4 of those residual data sets together and line them up correctly so that we can then construct the scatter plot that we want. So before we do all of this, let's go ahead and let's run each of these individually. All right, so let me scroll up here. And so let's see, we've constructed the data set, and we have constructed the ID variable, and we printed out that data set. And so now let's fit a regression model with y as a response and x2 as the explanatory variable, excluding variable x1. All right, and we'll get the residuals for that model. We'll go through these other steps, and we're going to print it out. So let's take a look and see what we get. And so here we have the regression analysis with y as the response variable and x2 as the explanatory variable, and we have this listing of residuals. Okay, and so here are the residuals from the model, y equal to x2. All right, and so we'll come back and look at those, but I just wanted to point that out. Okay, next we're going to fit a regression model with y as the response, but in this case, x1 as the explanatory variable, and do the same thing, get the residuals and print those residuals out. And so here we have the output from that analysis, regression analysis with y as the response variable and x1 as the explanatory variable. And then we list out the residuals. Okay, now let's fit a regression model with x1 as the response variable and x2 as the explanatory variable. And then say the residuals and print those out. Okay, so here are the residuals for the model. X1 is the response variable and x2 is the explanatory variable. And then finally, we will construct the 4th model, a regression of x2 as the response and x1 as the explanatory variable, and then we'll fit those residuals. Okay, and so these are the residuals for the model that has x2 as the response variable and x1 as the explanatory variable. Now notice that in this data set containing the residuals, we have the ID variable, all right, with values 1 through 25. If I scroll back up and look at the previous analysis, we have the ID variable with values from 1 to 25 and so forth. We're going to have that same type of structure in all 4 of these residual data sets. All right. And what we want to do is we want to take these 4 data sets and append them together. So this way, horizontally, and we want them to line up. Okay, we're going to use this ID variable to line them up correctly. And so the way that we do that is using that set of statements. So again, we're going to merge. We're going to create a data set, a new data set called residuals. It's going to contain the residuals from all 4 models. And then we merge those 4 output residual data sets that we just created, and we merge them by ID. We're going to line them up by ID so that everything lines up as it should. All right, and so let's take a look at what we get. Okay, so I have printed out the data set that we just created, and you can see here that we have 4 columns, 1 column for each of the 4 residuals that we calculated, or the residuals for the 4 models that we calculated. And so now we have exactly what we need to construct the partial residual plot. All right, and so the first plot is the partial residual plot for x1 given that x2 is in the model. And so again, what this is going to do, notice here that I'm using PROC SGplot, and I'm going to plot from the residuals data set that we just constructed. The y variable, the variable on the vertical axis, is y underscore x2 underscore resid. And so in the y direction, we've got the residual from the model, y equal to x2. Now the residual from that model is based on a model where the variability in y that can be accounted for by x2 has been used, but we've not accounted for any variability accounted for. We've not accounted for any variability accounted for by x1. Let me say that again. We've not accounted for any variability by x1, and so any relationship between y and x1 should show up in that residual. So that's a better way to say that. And then likewise, in the x direction, along the horizontal axis, we have the residual from the model where x1 was the response and x2 is the explanatory variable. And so what this represents, what this residual represents, is variability in x1 that is not accounted for by x2. And so when we plot these values against each other, that gives us the partial residual plot for x1 given that x2 is in the model. All right, and again, what this is telling us or showing us is any variability in the response that is associated with x1 given that x2 is already in the model. Or another way to say that would be variability that has not been accounted for by x2. And then similarly, to construct the partial residual plot for x2, given that x1 is in the model, the horizontal direction, y variable, we're plotting the residual from the model that has y as the response and x1 as the explanatory variable. If the response variable y is in fact related to x2, then that association should show up in this residual. And for the x direction, we're plotting the residual from the model that has x2 as a response and x1 as the explanatory variable. And so if there's any variability in x2 that it's not accounted for by x1, that should show up here. And so by plotting those two variables against each other, that's going to help us see if there is a additional variability in the response variable y that can be accounted for by x2. Okay, so let's take a look at this first partial residual plot, the partial residual plot for x1, given that x2 is in the model. And so we see here that we have y underscore x2 underscore resid on the vertical axis and x1 underscore x2 underscore resid on the horizontal axis. And we do see a trend. All right, this is the partial residual plot for x1, given that x2 is in the model. And because we see a trend here, and in particular a linear trend, this would tell us that the response variable y appears to be linearly related to x1 above and beyond any kind of relationship it has with x2. And so based on that, we would certainly include x1 in the model. All right, now let's construct the other plot. All right, and so again, we have, in this case, y underscore x1 underscore resid on the vertical axis and x2 underscore x1 underscore resid on the horizontal axis. This is the partial residual plot for x2, given that x1 is in the model. And so we have, when we look at this, we see an increasing trend, and it does appear to be linear. All right, and what this is showing us or telling us is that there does appear to be variability in the response variable y that is accounted for or could be accounted for by x2 above and beyond that which is already accounted for by x1. And so based on that, we would certainly include x2 in the model as well. Okay, finally, what we want to do is we want to show how to obtain the partial residual plots directly from PROC-Reg using the partial option. And so we have a partial option on the model statement, and this is going to enable us to construct the partial residual plots. We also are going to use the partial data option, and this is going to allow us to print out the partial residuals themselves, the values from which the partial residual plot is constructed. And in my invocation of PROC-Reg, what I'm going to do is issue, instead of saying plots equal none, we certainly wouldn't want that because we do want some plots. But we don't really want everything. We don't want all the plots that are generated because we want to focus on these partial residual plots. And so we're going to we're going to specifically select those plots. All right, so what plots do we want? Well, we want the partial residual plots. And then in parentheses, I've got the keyword unpack. And what that's going to do is going to display those plots individually. If we did not include this, then it would put all of those plots together in a paneled display. And it's fine to have that, but I just wanted to show you how we can get these plots individually. All right, so let's go ahead and run this and see what we get. All right, and so we have here let's see here, yeah. Okay, so this is where the output starts. So using the partial option in PROC-Reg to get the partial residual plots. And so we notice that we've not restricted the output this time by using the ODS select statement. And so we're getting virtually all of the at least tabular output that PROC-Reg will generate by default. So we have the number of observations table. We have the ANOVA table for the regression. We have information that shows the square root of the mean squared error, the R-squared value, adjusted R-squared value, and so forth. We have the table of parameter estimates. But right now we're really not interested in that. We're interested in the partial residual plots. Now there are some other standard plots that are printed out. All right, and we're not going to focus on these right now, but I will just show you that these are various kinds of residual plots. So we have the raw residuals versus the predicted values. We have the R student, the externally studentized residuals against the predicted values. as well as some normal probability plots and histograms and so forth. But what we're really interested in here are the partial residuals themselves and the partial residual plots. And notice that we have the partial plot data. Now, the reason we get this table of partial residuals is because of the partial data option here. All right, and so we have 4 columns of partial residuals. And if you were to go back and compare these values with the values above, all right, let me go up and print these out, you're going to see the same values. All right, we're using different variable names, but the values in these last 4 columns are the same as the values in these columns. Now, they may be in a slightly different order horizontally here, but for a given partial residual, you get the same values. Okay, then we have these 2, there are 3 partial plots. We're not going to be interested in the plot for the intercept, but we have the partial plot for y, for the partial residual for x1 here. So this is the partial residual plot for x1. And then we have the partial residual plot for x2. And notice that it's got the line of best fit for these residuals superimposed over the scatter plot. And if you go back up and if you compare these plots to the plots that we constructed by hand using SG plot, you'll see that it's the same type of plot. Except for the inclusion of the line of best fit here, they're the same plot. And so we can see that we don't actually have to go through and fit all these different models, to get those residuals, and then actually, and then fit the or create the scatter plot by ourselves. We don't have to go through all that work. SAS has implemented that procedure in PROC Reg, and so it's very easy to get those partial residuals and the partial residual plots just by using the appropriate options on the model statement and also in the plot statement. So that's what I wanted to show you regarding partial residuals and partial residual plots. We'll continue on with the next topic in the next lecture video. So see you then.